My name is Josh Long. That's my Twitter's address and my email there. The email's important, guys. If you have questions or concepts or thoughts or ideas or feedback, let me know. Send me an email. I'm happy to answer questions, happy to point you in the right direction, do whatever I can to help. I'm the Spring Developer Advocate for SpringSource. How many of you have heard of SpringSource? Oh, yeah. Good. Right on. And I'm the author of, what is it now, 4 books, working on my 5th. Let's never do that again. Oh, that is not good. Sing like a bird. I'm the author of 4 books, 5 books now, working on my 5th. The books there are some popular ones. The one on the right there is the O'Reilly book on Spring Roo. How many of you have heard of Spring Roo? Rock on. Spring Roo book is free. I got O'Reilly to give it away for the community, right? They're very invested in the Spring Roo community and they believe in it, just like I do, and just like the Vaadin team does. There's a good add-on for Vaadin for Spring Roo. We'll talk about that today as well. In particular, that's discussed in the book as well as on the website on vaadin.com. So go to springsource.org/Roo. Today we're going to talk about a lot of different things. We're going to talk about Spring, we're going to talk about Cloud Foundry, and we're going to talk about Vaadin. I'm going to package the whole thing together as a great way to get an application from 0 to 60, quickly, right? You need good-looking, useful technologies to do this. So we'll look at these different technologies in sort of the aggregate. As I introduce different pieces, we'll focus on each one. If you have questions, ask, but hurry, because we're gonna be so short on time. I'm not good with just 60 minutes. I could go on all week. And whatever you do, no tomatoes, okay? I don't know where you guys get these tomatoes. Who brings tomatoes to a development conference? Where do you even get them? I hate dodging those things, it's terrible. Anyway, so Cloud Foundry first. Cloud Foundry, how many of you have heard of cloud computing? It's always helpful to ask just to make sure that we're all on the same page, right? Cloud Foundry is the open source platform as a service from VMware. It's another different option. How many of you have heard of platform as a service in general? Just this idea, right? Basically, you say, okay, if I'm going to go to Amazon Web Services, I'm going to ask them for hard disks and CPUs. That's one way of getting the job done. At a higher level, you want to be able to say, instead of hard disks and CPUs, I want to rent infrastructure, running, working, application servers, things like that, messaging brokers, databases, etc. So when we sat down and we talked about how to build the next big platform as a service, we looked at the kind of things that we would want that platform as a service to have, right? The things that we thought were pivotal in delivering the best product for both ourselves and other users. And this is the list of things we came up with. We talked about the right to code, very important, right? We want people to talk about code first and then that's it. Right? There shouldn't be concerns of infrastructure and concerns of middleware. That shouldn't be something that should come into your mind when you're designing your next big application, the thing that'll make you rich. We also wanted people to talk about portability, right? This idea that you can take your application and if, for example, let's just suppose in some sort of crazy, strange world, maybe, something were to go wrong on one particular implementation, we didn't want you to be limited to that implementation. Not that there's any precedent for this, but, what if, for example, Google App Engine had announced that they were exiting beta, and what if, just in a hypothetical, they announced the pricing once they had exited beta, and what if, in that same hypothetical situation, that pricing was outrageous and it caused the whole community to cry blood? That would be a bad situation, right? Because these people would be stuck on Google App Engine. Not that that sort of thing has happened, or has it, but, if it did, you don't want to be stuck in that same situation. Same thing with Amazon Web Services. Do you guys remember last year when Amazon went down and a whole slew of websites, including Foursquare and the like, all went down with them? And there's nothing these guys could do to get out of that because they had built their applications to that particular cloud environment. They were limited to that cloud. We also talk about choice, right? Frameworks, technology. How many of you guys are Java slinging ninjas? Right on, me too. Well, I'm not a ninja, but I do sling Java. How many of you have met somebody who once knew somebody who actually touched a PHP script at some point? Right? Not that I do, but to each his own. It's choice, man. And we can't deny the fact that our applications exist in a melange of different environments, right? I don't know about your organization, but I know I've known a lot of different organizations where Java is not the only application type there. There's other frameworks, other technologies. Somebody's stuck in some sort of Ruby on Rails application, and we can't fire the guy, so he got away with it. Oh, anger. Same thing for services and middleware, right? I don't want to be stuck with the one true database or one true message broker. There's always choice. There's always better options, and frankly, being able to choose one based on its technical merits shouldn't be that should be the only thing that you have to be concerned about. You shouldn't be choosing a technology based on some sort of forced edict from on high, right? And transparency. When you go, it's like screen dancing. It just danced. Transparency is a big deal. When you deploy your application, it should be as available and open and readily monitored and inspected as anything that you've deployed in your own data center. So you should have full access to the logs and the patch dumps and all that stuff, right? Similarly, taking that philosophy just a bit further, we also talk about open source. It should be open source. That is a part of transparency. It's a function of transparency. When you build your application and something goes wrong, you want to be able to step through and see what's going on, right? So that whole thing, these virtues taken together, these comprise what we want in our cloud. And they're enumerated in developerrights.org, and they are behind everything we're doing with Cloud Foundry. When we talk about Cloud Foundry, kind of diving into the specifics now, Cloud Foundry itself is managed by an API. This API is divided into 3 different segments here. We've got lifecycles, we've got services, and we've got applications. And we also have sort of housekeeping, bookkeeping kind of APIs. That API is a REST controller. It's a RESTful API that you can interact with. So when we talk about these different things that we're doing in this talk, you should know that there are lots of different ways to approach that same functionality because they're all talking to that same RESTful API. So there's a Maven plugin, there's a Gradle plugin, there's a Gradle plugin, there's a Woo plugin, there's a STS and Eclipse tooling support, and there's support for this all over the place. Okay, first things first. Let's talk about the runtimes and frameworks supported by Cloud Foundry. Out of the box, Cloud Foundry supports Java applications, which we have established that's okay, we don't do that. Scala. How many of you guys are slinging Scala? Ruby applications and Node.js. Any of you doing Node.js? Just curious. I mean, I'm wanting to know what the community is doing. We also support Python. There's also different implementations. Other people, other community members have put together support for Python, PHP, Haskell. How many of you are slinging Haskell? Again, this is another one where I'm just wondering if this is like what people are doing all over the world, and I'm just missing out. There is Haskell support and Erlang support. Getting an application going on the command line is, up into the cloud is very easy. You can go to cloudfoundry.com and get a free beta account, for example. During the account, it's beta and it's free. It may not be free later on, pricing will be available. And as you see, that's not really that big of a deal because cloudfoundry.com isn't your only choice. Once you've got an application, whether it's a Java or Ruby on Rails application, whatever, it's easy enough to get that thing deployed. So here's the VMC push command. You specify the application name that you want to deploy, and then you specify the actual binary that you want to deploy into the cloud, and then you specify the URL, right? Here's what that kind of looks like. There's a prompt. Here's the prompt will actually, ask you questions, and you satisfy the prompts as you need to. So we'll say, is this a Java application? Yes, no, maybe. How much RAM do you want to give it? Do you want to bind any services? For now, we're going to say no, of course, because we have to hurry. And then it deploys, and then you get this nice helpful prompt telling you your application's going. So basically, what I didn't do here is I didn't sign up for the account in front of you guys and enter my information. But once you've got that account and once you've installed the VMC command line tool, that's everything you need to get a working application deployed into Cloud Foundry up and running. As we'll see, that can be even simpler. If you want to use something called manifest, which is a manifest.yaml file that sits at the root of your application, you can prescribe what services and what RAM allocations and everything should be available to the application that you deploy. So this can be taken from the manifest as opposed to being asked and filling out the prompts every single time you deploy something. So this makes it even easier to get an application into the cloud. let's take a look at that. Remember I talked about, different views, right? So all that VMC command line tool I just showed you is actually a RESTful, it's talking to a REST server. You can do it from SpringSource tool suite, which is an Eclipse distribution. Here I've got a WTP instance that I've configured inside of a SpringSource tool suite, and I've added it on the bottom left, like a server. I'm going to go ahead and add Cloud Foundry. I'm going to specify the URL of the server itself, the cloud that I want to talk to, and then I'm going to fill out this the server name and so on, and then I'm going to log in. I didn't do this before when I was actually deploying an application, but this is just like the Git command, the subverting command. You can target different clouds. There's not just one true API, one true cloud. So you can have local private, you can have public, you can have behind the firewall, you can have development and production, you can have whatever you want, right? So it's helpful to be able to say, I want to log into this particular version of the Cloud Foundry. Once it's there, it's just like any other server, one local server. You can actually debug through it, you can actually inspect the status of the actual app server itself, and, or helpful, you can actually create applications on the fly. Here I've double-clicked on the actual Cloud Foundry instance, and now I'm kind of inspecting it. Just for our benefit, our edification, I'm going to go ahead and create a simple Spring MVC application. Spring MVC is a web framework. It's very resource-centric, kind of lower level compared to nicer, more elegant technologies like Vaadin for beautiful applications. The point of this is to show that it's easy to get an application up and running very, very quickly, right? So I'm going to fill out this prompt. I'm going to give it a package, give it a name, hit finish, and we'll modify the application itself to be, a little more salient for what we're trying to do, but not too much, right? We just need to hurry. What this is going to do is it's actually going to download the kind of code you need to build the application, set up everything for you, and then we can modify the source code here, which is what I'm going to do. I'm going to modify the source code and say, welcome to home. It's just a controller. The idea is that when we deploy this application, we can make requests and responses to this application. We'll see the output, right? It's got a JSP page, but again, this is just a stock application just to show that it can work. Then we're going to change hello world to say hello cloud. And just like that, we've got a working Spring MVC application. You can drag it onto the WTP instance, and once you do that, you hit start. I'm going to hit publish first, obviously, just like anything else. And wait for it. Voila. So hit start, just like you would with anything else. It's going to ask you to give it a name. It's going to ask you to specify the URL, just like we did with the VMC command line tool, right? Same trick, different client. We're going to specify what RAM we want to deploy, or allocate for the cloud application. And then we kind of get going real quick. You can see the application starts up just like you would expect. It's got the output and everything. Finally, we get to the other side of it. You can see I can actually interrogate the application very quickly, right? So, nothing special. That's the point. You don't have to, for the very large majority of existing applications, this will be like what you've done before. Okay, let's talk about environments. Let's talk about clouds themselves, because I alluded to this before. This is actually kind of a special part of Cloud Foundry. This is one of the things that makes Cloud Foundry different from a lot of the alternative clouds. We are very much against lock-in. How many of you know this one song? It seems like this is the only Eagle song that everybody else knows. Have you guys, you know Hotel California? Yeah. Okay, it's a good song. And it's apropos. The idea is Cloud Foundry is open source, and we want people to be able to move their application to Cloud Foundry without fear of being locked in. It's not a one-way ticket. Once you get in there, and if you like it, you can move your application to other different versions of Cloud Foundry that better serve your needs if you're not satisfied with the one you're using. And this has, and because it's open source, also you can feel confident that your wills can be affected in the code base itself. Here's the Google App Engine. How many of you are using Google App Engine, by the way? Well, good. Rock on. Google App Engine is an option. It's a platform as a service as well. This is a Google Code ticket for PHP support in Google App Engine. This was actually originally added in 2008. There have been thousands of comments on this Google Code ticket. asking, people saying, yeah, I would love to have PHP support, please, that would be great. And at some point last year, in 2011, a Google engineer came to the ticket and I don't know how to, you can read it there, but what's wrong with the projector?
Nothing.
Okay. He basically muted the whole thread. He didn't want people annoying everybody each time somebody reestablished that they wanted PHP support. So his response to thousands and thousands of people saying they would love to have PHP support was to say, I'm going to try and mute you, quiet. This is not, it wouldn't be so bad in and of itself, but in the same time as they were ignoring that thread that had gone on for years, they introduced Go support. And, I don't know, is there a sudden outbreak of Go usage that I don't know about where it suddenly became more popular than PHP? Are you guys using Go everywhere? Every day. Every day, right? Okay. Well, I'm clearly on the wrong side of this one. I don't know. It just seemed like it was an obvious win. Okay. Well, anywho, back in reality, Cloud Foundry was released last year around April, around the same time. 3 years to the date, right? Cloud Foundry was released last year, and it's on GitHub, github.com/Cloud Foundry. And then within weeks of that being released, there was a pull request providing PHP support. This is a big difference. This is a very, very big mindset, a change in mindset, a change in approach. And of course, that code, as we'll see, has since gone on to become the PHP support provided by AppFog. So it's actually a business app. They don't have PHP support in Google App Engine. Somebody else has since made a business and started hiring employees and gone into production by providing PHP support on Cloud Foundry. That company is called AppFog, which is the first one we have up there, right? So I'm not saying you guys are going to be particularly interested in AppFog, but the idea is pretty interesting, right? The idea that you can have a fork of the code and you can add support for what you want. You can add support for what you want in the cloud, right? Add specializations. Take it in your own code, take it locally, specialize it, do whatever you need to, and make it your own, right? There's no reason not to. If you have a specific use case that's not being met, and you can't convince the benevolent engineers at VMware to add it to the cloud, no problem, fork it. It's easy to do. We have support from Node.js, and we have also backing by Joyent, the company that sort of shepherds Node.js. And we also have support for Python and Perl, right, from the ActiveState guys. These are the guys that make the IDE for Perl and Python. And they are also providing their own cloud based on Cloud Foundry called Staccato. So that should be very telling, right? There's a lot of different people that have invested in making this their cloud as well. If you want to take this cloud and run it locally, this is more for the ops people, or for you to go back and tell your ops people who are going to probably be freaked out by the idea of delegating everything to a cloud. If you want to run this stuff locally on your own cloud, in your own data center, behind the firewall, because for a lot of companies in a lot of different countries actually, moving their applications to a publicly hosted cloud is not a viable idea. How many of you work in a place where this is true? Are any of you from if you're working in a financial services company and you're dealing with money in the United States, you're under the very sort of tenuous regulations provided by Sarbanes-Oxley, which says that all financial information stored in an application needs to be auditable and it needs to be traceable. This is very true, and I think in most of Europe, you can't host information about financials in U.S. companies, for example, in a software provided by U.S. companies, for example, or hosted on U.S. soil. There's a lot of different things like this, but the point is, maybe you want the dynamicism and elasticity of the cloud, and you can't afford to trust a publicly hosted one. There's no reason that should stop you, right? If you're ambitious enough, you can use GitHub, go there and get the README, and actually set up the stuff on Ubuntu yourself. Or you can just set up the Juju and the Ubuntu script. You can actually use the apt-get, and you can use Juju itself to set up Cloud Foundry. There's a lot of ways to get this started at that point. Finally, for those who are developers like me, going back to where we're supposed to be, we have a pre-configured virtual machine that you can download for free, and it has everything you need to run Cloud Foundry locally in a single virtual machine instance. So now you can deploy on a train, on a plane, in an automobile, or on a cruise, for example, without fear of connectivity issues, right? So now you can develop locally, and you can replicate production completely, all just by downloading it. Okay, next thing. Let's talk about services. this to me, this is where I get really excited because there's a lot of choice here, right? And how many of you have spent time setting up, MySQL is a good example, different services on your own machine to get it running locally? Well, a lot of these services, a lot of these infrastructure pieces are natural to install after a few years. They have a Windows script, but maybe they don't originally. I know Mongo for a long time was very difficult to get running on Windows. So having something that would just make all that go away and be exactly consistent with production is a very valuable thing. Services on Cloud Foundry, we mentioned the pre-packaged ones, we mentioned Redis, we mentioned RabbitMQ and MongoDB and MySQL and Postgres, but it's an extensibility thing. So if there's something that's there, or something rather that's not there, and you want to add it, there's no reason you couldn't. The actual code to teach this cloud about a new service is quite trivial. If we don't have something that you want, like I said, it's easy to add, and I have some use cases that I would like to see. Maybe you guys can help me. I think, besides those Erlang and Haskell hackers out there, I think there's a huge market for COBOL. What do you think? No? Yeah, kicks? Come on, that's it. I'll tell you guys a secret, just between you and me and the walls. There's two organizations in most Java companies. There's the young, lean, hip Java developers on the first floor, and then there are the neck-bearded types on the second floor, the guys that were around in the 60s, and those are the COBOL programmers, and they make more money than we do. And there's a reason, because those guys control kicks, and they can make that horrible stuff work. So the sooner we bring that to the cloud, commoditize it, and make it less of a pain, I think is going to be a big deal. Anywho, going back to command line world, if you're using the VMC command line, the VMC tool, it's easy to add a service to your application and to your account. So here I'm going to say VMC create service, and I want to create a service of type MySQL, and I want to give it the name MySQL1, right? From there, I can actually bind that service to my application, right? So this is very powerful. I can create as many MySQLs or Postgres or whatever as I would like. Or if you guys add COBOL support, you could add as many kicks COBOL support as you want as well. And it works all through this SPI. I can bind as many application services to as many applications and in any cardinality. It's also easy to inspect what services you've got. Once you're in an application, once you're running it in the cloud, you can actually pull down the environment variable. There's lots of other environment variables like this, but it's just helpful to know that in the worst case, if everything should go completely wrong, you can still pluck the VCAP services environment variable out of the environment using system.get and introspect it. Not that I recommend you do. We have a better way, as we'll see soon, but it's just nice to know that that's there. So what happens when you get that service available? What happens when you get that service up and running inside of your cloud? You're still going to have those persnickety operations people, those system administrators who are not going to be happy with the idea of a cloud maintaining the service for them, right? They want their job. They're, as much as you'd like to fire them and as much as they need a shower, they still have things they want to do, right? Maybe it's a backup script or something that needs to run at night. Either way, you need to get in there and work with that data. So we have the tunnel. This is the Caldecott Tunnel in San Francisco, in Northern California. It's a tunnel. The engineers, we have some nerds that were up all night working on that. The name. They were like, we need a nickname for a tunnel. And they spent all night and they came up with that. Oh, makes me very sad, but it's okay. Anyway, just think of it as a tunnel, right? The idea is that it lets you access the services that are provisioned in the cloud locally, right? So here you go, gem install Caldecott. This is the gem that it's a Ruby gem. It's what installs the tunnel mechanism. Once that's installed, and by the way, you won't have to do that in the future, but for now it's required. Once you've got that tunnel installed, you can do VMC tunnel and you can point to the service. In this case, MongoDB or whatever. But once you've done that, it'll set up a connection and forward all connections through a port to the public cloud so that you can access it locally. So if you want to run your interactive shell script and do command line spelunking along your data, no problem. It'll give you the username and password and the DB that you need to point to be able to access that service from any kind of tool, right? So if you're using the command line tool or whatever, that's fine. If you want to use your favorite UI tool to navigate these services, and I'm using MongoDB here as an example. If you want to use MySQL, MySQL admin or pgadmin or whatever, right? all this, the idea is the same, right? You plug in that information, and boom, you have instant access to the services that are found there. So okay, so how many of you are Spring developers? That was the high-level sort of spiel about Cloud Foundry. Just get that out of the way. It's a great way to get your cloud into, in a hosted environment quickly. That's the idea. It's a great way to get rid of the people that set up your infrastructure. It's a great way to avoid having to file tickets to get some hardware set up somewhere. It's a great way to sail right past all that and get your application to where it needs to be. Dealing with environments that use a cloud is a different story. Indeed, dealing with enterprise applications in general is a different story. And for that, of course, I'm the first guy to admit to say that we should use Spring. Spring's been around for a long time. How many of you are using 3.0-ish? Spring? Okay. So I'll give you a quick recap. Basically, Spring is a component model that sits above your lower level infrastructure. So, for example, if you're using a sort of legacy application server like, guys, you guys are Vaadin people. You guys are awesome. I need this to be a certain number. It needs to not be anything else because I'll be very sad. How many of you are using WebSphere? I saw you. But yeah, that guy. But otherwise, hopefully that thing's a dead dinosaur. And there's a lot of different choices out there that are better, right? We have a lot of different technologies. I mean, you can choose from any of these other legacy application servers. There are lightweight application servers like Tomcat, for example, that you can use. And more importantly, a lot of times, nowadays people aren't targeting an application server; they're targeting a platform as a service, the cloud. So Cloud Foundry, Google App Engine, what have you, right? Once they build their application using Spring, it's easy to move that application from one server to another or one environment to another, because you're insulated from the lower level bits underneath. And once you've done that, you can now take advantage of these different technologies on the top, right? So Spring provides different specific vertical integrations for web applications and for big data and mobile and messaging and all that. In practice, that support manifests itself as a series of different projects, which are easy to add to your application based on your need. They're just jars. You don't have to use them all at once. There's no distribution or whatever. You just add them down, pull them down, and add them to a class path as you need it. Getting Spring in your application is pretty easy. You can see here we've got an application context. You're telling Spring, hey, I want you to look at this configuration information, and then start up and manage the objects that we provide. Doesn't matter what environment you're doing it. Here's a public static void main or a web application. Let's quickly look at some of the cool stuff in Spring 3.1, which just came out last, December, so 3 months ago. Spring 3.1 is a sort of an evolution of the concepts that were laid out in Spring 3.0. The idea is that you've got a completely Java-centric component model, right? Here we've got a configuration class. You can tell because it's got add configuration on it. And we've also told Spring, hey, I want you to look in this package for all the beans that are in this package, and I want you to start them up and manage them for me. And it'll find all the beans in that package that have annotations on it and then manage them as well. This is kind of like what the XML file used to do. I mean, you can still use the XML, but I think the Java configuration style is a much more elegant approach for a lot of different use cases. To use Spring, it's the same as before. Here I'm actually saying application context AC equals new annotation config application context. I'm going to point it to that configuration class that we just looked at, which is empty and kind of naked at the moment, but we'll get back to that. I'm going to also add a service in that package, right? I'm going to create a service bean that does, typical sort of service facade that actually manages data inside the database for you, right? This is just a contract. You can see it's got nothing else in it right now, right? Right now it's just, I've got a method that's going to give me a customer. It's going to create a customer, give it a first name and a last name and a sign-up name. I haven't specified anything else. Let's suppose I want to now add database support. Let's suppose I also want to use the very, very new and recently released Hibernate 4, right? First things first, I need a data source. Spring can't do anything for me if I don't have a data source, so I create a bean definition. When I create that bean definition, it's going to add bean, right? Spring's going to look at that class and it's going to go through the methods on the class and register the return value of those methods in the container for me. So it's the same thing as doing the bean XML element in the old XML class, right? It's the same idea. It's a bean XML. The name is called data source, and the class is a type data source. and you can configure the object any way you like. I'm also going to need a session factory, Hibernate session factory, so I can add another @bean here. The bean, in this case, is going to use a local session factory builder, and it's going to reference the data source that I just created. So data source, and it's going to call this.data source. See that? That's how you do the equivalent of doing a bean property ref, where you reference another bean. So now you got two beans configured in your Spring configuration file, your Spring configuration context. Finally, to be able to take advantage of that, going back to our little service object, I can inject the session factory using standard annotations, and then I can create that method, and I can actually use Hibernate just like I would like to. And this is a good start, but of course, it's not quite the whole picture, is it? I actually need to, take care of transactions. I need to declare the transaction management. So here I'm going to add @enable transaction management to my configuration class, and then I'm going to register another bean. This one is a platform transaction manager. And the transaction manager is Spring's SPI for handling transactions. If you think about all sort of transaction management strategies across different technologies, whether it's JVC or JMS or AMQP or JTA or JPA or Hibernate or whatever, they all have this idea of begin work, do some work, batch, and then commit, and if it works, good. If it fails, roll back, right? Well, the Platform Transaction Manager API codifies that. It's a strategy for all those different types of technologies. So here, I've got a Hibernate Transaction Manager. Once I've got that, I can now go back to my service code and add transaction to the methods. And Spring will automatically start a transaction at the beginning of the method and then commit it at the end. Right? It does the right thing for me. I also want declarative caching. For example, if I create an object, or if I do a query on an object that has the same key, there's no need to go back to the database each time. So I'm going to say @enable caching. Turn on that feature, and then I also need to provide a cache manager. There are several different implementations. You can use EHCache, or you can use Redis, or you can use Gemfire, you can use anything that works with the Java.util.map. In this case, I'm just going to use a regular map, concurrent map cache. And I'll provide regions. I can now go back to my service class and add caching, so that whenever somebody calls this method, the result, if it already exists, it's going to be stored in the cache and then returned. So it doesn't actually go back. It doesn't create the same object. It doesn't do anything like that. Consult the cache first. Okay, so Spring is clearly a good way to get your application working, but let's be honest, you can't escape. You can't escape some kind of ugly code. There's a lot of things that are, Java is not without its warts. Let's just be 100% honest about that, right? There's no way to do a lot of things that you would do with more dynamic languages like Rails, for example. And indeed, some things don't map nicely to Java anyway, like view creation, right? You need view templates, you need things like that. Some frameworks have sidestepped Java. They sidestep Java, and they provide a language that is capable of doing these kind of things. So, for example, if you've used Rails, you're using Ruby, and that's how you get around some of the works that have appeared inside of Java itself. You provide a nice language, and then suddenly you're able to do more dynamic things. Rails is great, but I'm still working with Java. I like Java. I just want a way to make a lot of the sort of ugly sort of code go away, and I also want to be able to do things more sort of domain-driven style, right? I want to be able to say, here's my domain, here's my entities. I want things to be generated on my behalf. So Spring Root is the way to do that, right? Spring Root is a framework from SpringSource that provides support for code generation, if you will. It's a very opinionated technology. It's just like Rails, just like Ruby and Rails. The idea is that you have conventions, and as long as you comply with those conventions, then you're able to now build applications much more quickly, right? More rapidly. So Spring sits underneath it, of course, but now you're dealing with a higher level. It's got a shell, and you can use that. So first things first, it's 100% Java. The code that's generated is 100% Java, and you can run it and deploy it without actually, you don't have to do an end run around your system administrator asking for permission to include a new framework. There is no extra runtime component in production. It uses the Spring technologies, but it makes it easy to add them without actually becoming experts in all these different domains, right? So if you need security, it's easy to add that in with a command, as opposed to learning Spring security, which is easy enough, but still, that's time. It supports a lot of different standards. So, for example, if you're using JPA2 or JSON 330, yes, all there, of course, servlets, etc. And it's a command line tool. So it's very, very sort of, it's easy to script, it's quick, and more to the point, it's quick to batch around. You can make mistakes, roll back, try again, do that kind of stuff, right? A lot of different add-ins, a lot of different plugins, a lot of different ways, a lot of different extra support provided by the community. There's obviously support for, Spring security and all that stuff. My favorite is the Vaadin one, right? The Vaadin one is actually really, really good. It was an honor to be able to play with it when it first came out last year. And we'll look at some of the machinations of that added in a bit. But basically, Brew is an engine. It sits there while you're coding, monitors what you type, and then reacts as a result of that. So when you type something in Brew, the engine sits there and it looks for all the code that has Brew annotations on it, and it provides services for those annotations for you. It can do things like, okay, if I type in a field in an entity class, it'll automatically add getters and setters, right? If I type in, if I add a field to an entity class, it'll automatically provide a toString and an equals and hash code implementation for me as well. A lot of these things are things that you could do through some weird witchcraft using proxies and all that stuff, but why? Most of the time you're going to write them by hand, and it's just tedious. Much better to let Spring Boot do it for you. And then if you change the field name, it'll update those things for you. So it's interactive. It's not a one-way code generation trick. As you work, Spring Boot is going to monitor what you type, and it's going to update things to keep it in sync. It also creates a secondary file that sits adjacent to your code called an AspectJ intertype declaration. The intertype declaration is a file that contains extra functionality that's going to be added to your class. When Spring Boot is compiled, those aspect files get merged into your classes so that the resulting code is just a regular class. There's no weird extra component or anything. And it's also important to note that all of that stuff can be refactored out. If you don't want to use Brew, you can click a button and say, factor out all this stuff, and all your code now becomes regular Java code. So most of the time you're not going to see this. And the result is Spring Boot can write all this kind of boilerplate code that you don't want to write for you on your behalf in the background. Here's an example. I've got a class that I'm running in Java, and behind the scenes it's going to create an aspect, and then it's going to create those getters and setters. When it gets compiled, the person.class is going to have the field as well as the getters and setters, right? So creating a Spring Boot app is easy. There's a command line if you want to use that. You don't have to use Eclipse. There's also good IntelliJ support, but I think Eclipse is. You guys using Eclipse? Rock on. So this is going to work for you. Here we're going to create the sort of canonical pizza shop that we've all seen and loved from the Vaadin technologies. You can actually see, it's a regular prompt. It's a wizard that you go through inside of SpringSource tool suite, which, by the way, is a free download from springsource.com/developer/STS. You can fill out the information. So I want the project name and the top level package. The rest of it you can kind of leave empty. Once you've got that, SpringSource tool suite will dump you into a sort of a shell, and it's up to you to tell Spring Boot about your domain model, right? There's a lot of different ways to do it. You can actually create, using commands, your domain model, or you can use something called database reverse engineering. So it'll take a look at your domain model, for example. Here's one domain model, and automatically generate the JPA entities that you want. It's very easy to get that to work. So, for example, here's the database properties for a database reverse engineering root commands to get it to generate all your JPA code from a database model. But it's also easy to declaratively create the domain model using the Spring Boot shell. So here I'm creating the domain model for the pizza shop, right? You can actually say entity -- class, and you provide the package into which that entity is supposed to be generated. And you can also specify that you want tests to be generated, right? You can see that I'm using tilde.domain.topping. That tilde is a prefix. It tells Spring Boot, I want you to use the package that we specified in that original wizard. That's this guy here at the very top. It's his top level package name. I want you to use that package as the base, and then prefix all the rest of this package with that. So it's actually the full package .domain.topping. I can add fields here as well. I can do all these things, and then voila, I have a domain model. And this is scriptable, so you can actually take those commands and put them in a script file, and then run them again. So it's easy to create reproducible builds that are very easy to use over and over, right? Once we've done that, we've got a working service tier. You've actually built, I mean, I haven't shown it here, but the result at this point will be a working application that has support for Hibernate and JPA, and it has a working connection to a database, and it supports transactions, and it's got that whole domain model already set up in JPA, right? In these very, very small few commands. So now you've got a working service model, but the next big question that you're going to have is, how do I make this thing? I need a web application. I need to administrate this thing, right? How do I get this thing on the web? And if you're like me, you're going to reach for something that's got a lot of finesse, a lot of sex appeal, and that's usually the Vaadin add-on. Adding the Vaadin add-on from inside of Spring Boot is pretty easy. Here you have to tell it that you want to trust this PGP key. Once it's done that, Spring Boot will know about the PGP key, and then from there you can accept add-ons provided by that PGP key provider. You can tell it that I want to accept all terms of uses, non-interactively. Voila, easy. And then you say add-on search Vaadin, right? And this is the basic process for all add-ons. We're going to go through it here for Spring Boot. Can you guys see that in the far off corners of the room? Now, awkward. Right. I want this to be front and center. The only thing you need normally is that. Let's see what happens when we do that. Now. Yeah. Okay, well, nonetheless, I'll provide the slides on the intertubes shortly. Anyway, you do add-on install, provide the ID, and you say I want the first search result to come back. In this case, it was the Vaadin plugin. And I want it to install the results of the last search. So it's going to do that. I'm going to specify the search result ID and install it for me. Now that it's there, this is why it's kind of hard to talk at these. I mean, Vaadin is way too easy. You got to make this more difficult because it doesn't. It's hard to talk for a whole hour about just Vaadin. Not a lot to slow you down. Not a lot of friction. So here's the two pieces that you need to get Vaadin to automatically generate a beautiful looking UI for your domain that we've just generated using the Spring Boot, right? So I'm going to do Vaadin setup application package. And it's going to use the base package .web. So all the classes that are generated will eventually land in the .web package where you can use them. I'm going to tell them to use a theme, which is the pizza theme here. And I'm also going to tell them to use the JPA container. Because remember, we've got JPA classes already. And Vaadin knows what to do with JPA classes in particular, knows what to do with lazy loading and all that stuff. So why not, right? That will install Vaadin, that will install the artifacts you need for it, and it will also install support for using it from the visual tooling, which we'll look at. Finally, we want to actually say Vaadin generate all. This will go through all the JPA classes and generate the CRUD APIs, right? The result looks something like that. The top one is the one behind it in the back is just sort of the default view. And if you click on one of the entities that you're going to introspect, you can see it did the right thing for those models, right? It managed all the one-to-many relationships. It did the correct thing for the one-to-one relationships, and it provides nice-looking UIs for all of that. This is a Vaadin project, however, and you can take the resulting Spring Boot application, the resulting Vaadin application, into the Eclipse plugin from editing UIs in Vaadin, and it works just as you'd expect, right? It's all round-trip friendly and everything. From here, I can make tweaks, labels, and so on. I can use the visual designer, and then the results are manifest inside the actual runtime, inside the actual code that's deployed to run again. So, very powerful setup, right? Okay, so that's the big pitch, right? You've got a whole bunch of different things you need to get done really quickly. You need to manage your application. You need to be able to glue the APIs together. You need to provide services and infrastructure to test with and deploy against. And finally, you need a good-looking application. The last bit is sort of the most important one, I think, for most people in the corporation. So the last bit is why I'd recommend you start with Vaadin first, of course. I don't know about you guys, but how many of your bosses are How many of your bosses care about the pretty pixels first? I mean, the background, they don't care what the background is written in as long as it's pretty and it looks like it's going to work and all that stuff. I think that's pretty simple. And so you got to make sure that that particular decision is going to knock them out of the park. You know, it's going to knock it out of the park, right? So I think we have some time for how we do it time.